Welcome to The Explainer. Today, we are diving into a really cool case study in high-tech healthcare, taking a look at how one of Asia's biggest hospital networks is completely tearing up the rulebook on how they handle their most critical data. First, let's just get a sense of the scale we're talking about with the Medanta Hospital network. This isn't just one building. We're talking about a massive enterprise with 7 major hospitals and a bunch of clinics spread all across different cities. Okay, now imagine this. That huge network has to manage 1.4 million medical imaging studies every single year. We're talking X-rays, CT scans, MRIs. The sheer volume of that data is just incredible. And it's always growing. And get this, all that vital patient data is flowing in from over 300 different imaging machines dotted across the entire network. Every one of them is a fire hose of information, all feeding into a system that has to work perfectly all the time. So you've got this massive scale, right? And that's where you hit the central problem. Trying to manage this colossal wave of data is a huge challenge. And it's not just about finding a place to store it. It's about speed, it's about access, and it's about the kind of collaboration that's absolutely essential for taking care of patients. The core of the problem, and the source material really spells this out, is something called data silos. Because you have all these independent systems in different cities, patient information gets trapped and fragmented. It makes it incredibly hard for doctors to work together efficiently and just slows everything down. And this brings us to the tech that's really struggling to keep up. The traditional way of doing things uses what we call a monolithic system. Just think of a giant single chunk of software where everything, storage, viewing, workflow, it's all fused together into one rigid, inflexible block. You know, the source material just frames this perfectly. This quote really gets to the heart of it. It highlights the big weaknesses of the old way. It's rigid, it locks data away in these separate little boxes, and trying to change or adapt it costs a fortune. And this slide just lays out the difference in thinking so clearly. On one hand, you have the old monolithic way, which is like a brick wall. It's rigid, you're locked in, and if you try to change one brick, you risk the whole thing crumbling. The new approach? It's like a set of building blocks. It's modular, it's unified, and it's designed so you can change and upgrade it piece by piece, continuously, without any big disruptions. So what's the solution to all this? Well, it's a pretty radical new idea called a deconstructed PACS. Now, PACS just stands for Picture Archiving and Communication System. It's the brain that handles all those medical images. And by deconstructing it, you change the entire game. The big idea here is to break that giant single system into smaller, independent parts. That Lego block analogy is just perfect. The part that stores the images, the part that lets you view them, the part that manages the workflow, each one is its own separate block. And that means you can swap one piece out or upgrade another without having to tear down the entire house. And when you build it this way, you get some huge benefits. For a network like Medanta, it means they can grow and scale almost infinitely. It means they can support every single medical specialty, all under one unified roof. And maybe most importantly, it's AI-ready and vendor-neutral. That means they can plug in the best new technology from any company they want, which basically future-proofs their entire system. Okay, so that's all great in theory, but what does this actually look like in practice? How does it actually make life better for the doctors and patients on the ground in a real high-pressure hospital? Let's take a look. So let's follow a single patient scan on its journey. First, as soon as it's taken, it hits a super fast local cache right there at the hospital. That's for instant access. Then it's managed by a central cluster, gets stored for the long term in an open archive, and finally, it's backed up for disaster recovery. It's a really smart, multi-layered process. And this whole system is built for one thing, pure speed. A massive 85% of the scans, the most recent ones that doctors need right now, are pulled directly from that local zero-latency cache. For doctors, that means the images they need pop up instantly, no waiting. Okay, but what about that other 15%? What about the older files that aren't sitting in that local cache? Well, if a doctor needs one, the system just automatically pulls it from the central archive in, get this, less than a tenth of a second. It is practically instantaneous. That frustrating wait time is just gone. So yeah, this new architecture absolutely solves today's problems with speed and access. But its real power, its real magic, is how it creates a foundation for the future of medicine, for all the big innovations that are coming tomorrow. And this is the whole point, right? This deconstructed approach becomes a launchpad for innovation. It makes integrating AI seamless. It creates unified workflows for every single department. It supercharges clinical research. It also provides rock-solid data security that's ready for new regulations. And it guarantees the kind of 24/7 uptime that modern healthcare just has to have. Now, obviously, you don't just flip a switch on a system this huge. That would be chaos. A project like this gets rolled out in careful, manageable phases. You start by setting up the core backbone, then you integrate all the existing systems, then you deploy the special tools for each department, and finally, you build a team to make sure it all works together seamlessly. All of this with zero disruption to patient care. So, at the end of the day, what should you take away from all this? While Medanta's challenge with medical imaging is really a perfect snapshot of a much bigger trend. And it leaves us with a really compelling question to think about. As all of medicine becomes more complex and more data-driven, could this modular, deconstructed way of thinking be the blueprint for all hospital technology in the future?